it's time for one of our more advanced topics, the elasticity of supply. So what is the elasticity of supply? Well, basically it's a function of the slope of our supply curve. It's very closely related to the slope of the supply curve, but we're going to take the slope and do two things to it. We're going to modify it slightly so that it's unit free, meaning we're not going to be worried about is this in US dollars per bushel or is it in British pounds per kilogram. We're going to remove any units from the number we're going to give you, so there's no units in it. And we're going to convert things to a percentage because allegedly that makes doing the math easier, but we'll see about that. So let's just dive right into it. With a good example, let's imagine that this number, the elasticity, is equal to 1. If the elasticity is equal to 1, then that's going to tell us that if the price falls by 2%, the quantity that the firms are going to produce is going to drop by 2%. Note again that this is not a change in supply. When the price changes, the quantity is going to change. The supply does not change. Here is the formula that I would like for you to write down and memorize and use. The elasticity of supply, ES, that's actually a lowercase Greek epsilon. That's what we use for the symbol for elasticity. Sometimes we'll use a capital E, and that subscript S tells us that it's the elasticity of supply. It's equal to the percentage change in Y divided by the percentage change in P. Or we might express it, it's the same formula, just rearranged a little bit, as the change in Y divided by the change in P multiplied by P1 over Y1, where in this case the 1 represents our starting price and quantity pair. And that would give us the elasticity at a specific point at P1, Y1. That's why we call it the point elasticity formula. There is another formula floating around out there. It's called the arc elasticity formula, and it's going to give you the average elasticity between the 2 points on our supply curve, P1, Y1 and P2, Y2. A lot of textbooks push this arc elasticity formula on students. I don't particularly like to use it. I like the point elasticity formula better. The main reason is that these elasticities are actually only really accurate if we use calculus, and for this particular course that I'm teaching today, students aren't required to have calculus before the class, so we're going to use one of these linear approximations to the actual calculus number. And I look at it like this. The arc formula is longer with more things to calculate and it takes more math, and the point formula is short and simple and easy to do. And if they're both approximations to something else, why not use the short and simple approximation? But hey, that's just me. I kind of like to make things easy for you. So here's an example. I like examples. Here's a supply curve labeled S1, and on that supply curve I picked 2 points, P1 where the price is 10, and that goes along with the quantity of 4, so Y1 is 4. And let's imagine that the price of our product changes. Let's say it goes up to P2, which is $10.50, so it goes up 50 cents. And as a result of that, for this particular example of a supply curve, the firms in this market respond by increasing more, so the output goes up to 4.5. And you can quickly see that the change in price divided by the change in the output is going to be equal to 1, right? Because the price changes 50 cents and the output changes by 0.5 as well. Now 1 what, right? Because the units would be dollars per output or output per dollars or something goofy like that. So just kind of off the bat, the units are goofy, but the math's pretty straightforward. We're just going to see the price go up 50 cents, and then the quantity is going to go up by 0.5 as well. So let's plug that information into our formula for the supply elasticity. So I've taken the formula and trimmed it down a bit to just the relevant part. There's 2 ways to express the formula, and you got to use the right one when doing the math. So in this case, the change in Y is going to be 0.5, and that goes on the top of our first bit of the fraction. And the change in P is going to be 0.5 as well, and it goes on the bottom. That's where the 0.5 over 0.5 comes from. Starting price P1 is 10, so that's how the 10 got on the top of the fraction as well. Starting quantity is 4. That put the 4 on the bottom of the fraction, Y1. So 0.5 times 10 is just 5, and 0.5 times 4 is just 2. So the elasticity of supply is 5 over 2. That's 2.5. Now that number we get gets to be very important for this reason right here. We can use the elasticity as a way of classifying goods and use it to kind of predict how firms are going to behave. If we know the elasticity, we know how firms will respond to a price change. If the elasticity of supply, as in the previous example, is greater than 1, then we say that the supply is elastic. That means that firms are going to be responsive to the price. That means when the firm sees the price change, yes, they're going to change their quantity because that is what the law of supply tells us, but it's going to be a relatively larger change. So these firms are very responsive to the price. In other words, the percentage change in our output, percent delta Y, is going to be larger than the percentage change in the price, percent delta P. And as you look back, you'll notice that that's going to be the case in the previous example. Let's hit the next slide. All right. Another way to classify is when the elasticity of supply is less than 1, then we say the supply is inelastic. Now, quick time out here. This terminology is goofy. We have an elasticity that can be elastic or it can be inelastic. Don't blame me. I didn't come up with the terminology. An economist named Alfred Marshall back in 1890 came up with this. We can blame Alfred Marshall for it. I wouldn't have called it elasticity and then classify goods as elastic or inelastic because that's confusing, but that's the notation, so we have to learn it. In this situation right here, when the supply is inelastic, our firms are not very responsive to price. They're still going to follow the law of supply. When the price changes, they're still going to change the quantity, but the difference is the quantity change is proportionately smaller than the price change. And so if the price change were to go up 1%, our quantity change would be less than 1%. So the percent change in the quantity is less than the percent change in the price. The final way we can break goods down using the elasticity of supply is right here. If the elasticity of supply is equal to 1, then supply is unitary elastic. In that case, the percent change in Y is equal to the percent change in P. So there's like a 1-to-1 ratio expressed as percentage in this case. So if the price were to change by 5%, the output changes by 5%. If the price changes by 10%, the output changes by 10%. Why don't we jump into an example real quick? Let's say, for the sake of argument, I were to tell you that the elasticity of supply for some good we might be studying is 0.25, and that the price went up by 4%. How would you find the change in quantity expressed as a percentage? Let's take a look and see what we get. Well, the first thing we do is write the formula down. That's always our go-to thing. If we need to know the answer to a question, we want to take our numbers and take our formula and write them all down and start plugging numbers into formulas. So in this case, the elasticity of supply is equal to the percent change in Y divided by the percent change in P. Plug the numbers in. We get 0.25 is equal to the percent change in Y over 4. We rearrange that by multiplying both sides by 4, and that gives us 4 times 0.25 is equal to 1. So the percent change in Y is 1 in this case. So when the price changed by 4, right, went up by 4%, we got a 1% increase in our output. I think that's the last slide. Thank you very much for watching this video. There'll be some more examples popping up and some more slides coming up soon. Thank you.